When creating a composable in Jetpack Compose, it's okay to define your state inside your composable. However, it's preferable to try to move the state out of your composable as much as possible. The act of moving the state from a composable to its color is called state hoisting, and in this video I'm going to show you how to do it. So I switched to Android Studio. I have the project that we created together, and as you can see, we created our state inside our box screen composable. We created a state variable called count that determines the number of child boxes that we will eventually create inside the parent box. But what if we want to hoist the state count out of box screen to its color, which here is set content. So let's do that. In order to hoist the state from a composable, you need to pass in a variable to that composable that determines the value of that state, and also another parameter that determines what the composable should do when that state is supposed to change. Let's see that in action. So I'm gonna tell box screen how many counts I want for the boxes. So I need to create a parameter for it, count. Its type is integer, and also I need a handler. I need a lambda that tells box screen what to do when it wants the count value to change. So I say on count change. This is a lambda and it requests the color to change the value of count. So when you define a lambda signature, you define it this way: an empty pair of parentheses, and then the right arrow, and then the return type, which is often unit in Kotlin, which means we don't return anything. But note that we will want to tell our parent, our color, to change the value of count to a new value that we are passing. So we need to pass in a parameter to that lambda, and its value is of the type integer. So I specify int here. Okay. Then, because we want to move the state out of our composable, I'm gonna cut this line, which is the definition of the state, and I'm gonna paste it inside set content. So this initializes my state to an initial value of 0. So I pass count to box screen, and also I know that box screen also has a parameter, a lambda parameter, that it uses to tell us to change the value of count. It doesn't directly change the value of count. Please be careful here. It just asks us as the color of box screen to change that value. So I know that we have a lambda here and we are passed a parameter of the type integer, and it's the change, in fact, is the new value of count, new count. So I name it new count, and once we receive it, all we have to do is to set count equal to that value. Count equals new count. And we have a warning here that tells us, because our last parameter of the function is a lambda, it's better to move the lambda out of the parentheses. And this is a rule of Kotlin that tells you it's better to move your lambda out of the composables parentheses when it is the last parameter in the list of parameters for that composable or function. So again, because this part is the second parameter, is the last parameter for the function, and it is a lambda, then we can move it outside of the parentheses. So I do it. I move the parentheses to before the start of this lambda, and the warning is gone. In fact, you can see this usage in a lot of Jetpack Compose's built-in composables. For example, in the case of box, here is the content section of the box, and this is a lambda part. But because it has been a lambda, it has been able to move outside of the parentheses. But we know that it has been a parameter of the box composable, and we can make sure of it by checking the list of parameters for box. As you can see, modifier, content alignment, propagate min constraints, and finally content, which as you can see from its function signature, it's a lambda. So if your last parameter for the function is a lambda, it's better to move it outside of the parentheses. But why? Why do we do that? You can see by looking at this code that by moving your lambda outside of the parentheses, your code is more readable and more beautiful. And this usage allows us to write more straightforward code and more intuitive, because we know that in this section, when we are opening a pair of curly braces, we are opening a space, a scope for creating content. And this holds true for almost every composable in Jetpack Compose. For example, for row, we have this rule, for column, and so on and so forth. But back to our topic, state hoisting. So we created our code to hoist the state and also set the new value of count here. But there's something left to do in the body of box screen, where we will want to request the change in the value of count. So when we press the increase button, in fact, we should ask the caller to make a change in the value of count. And the change that we want is adding 1 to the value of count. So here, instead of directly changing the count, because we don't have the permission to change it anymore, we will want our parent, our caller, to change it. And because our caller has given us onCount change, we can use it to ask for change in the value of count. So I use it on count change, and the value that I want the new count to be is count plus 1. And what if the user presses the decrease button? In that case, I need to make sure that count is not going to be less than 0. So I do a simple check, and I say, again, note that I'm using onCount change. OnCount change the value of count to this value that I'm passing. If count minus 1 is less than or equal to 0, then pass in 0, then return 0. Else, otherwise, return count minus 1, because this button is supposed to decrement the count value by 1. So, on count change, if count minus 1 less than or equal to 0, return 0, or pass 0 as the parameter of onCount change. Otherwise, pass count minus 1. This is the new value that we want count to have. So let's run our code to see if it works the way we expect. Before running it, in fact, we need to make some change in the body of our preview as well, because our preview is calling box screen and it is using the old format of box screen. But we know that we have changed the signature of box screen, and now it has a different way of calling. It takes 2 parameters. So in order to save time, I can just copy the code that I have inside setContent for preparing the state and passing it to box screen. I can use it inside the preview composable, but we are not going to use preview. I'm going to run the application and get the output from this section, because running the code on the emulator is more performant on my machine than running it in the preview section. So let's run the code. We wait for the application to be built and installed on the emulator. Alright, the application is launched and I press increase. There we go. This is 1, the value of count, and we have a single child inside the parent box. Increase it by 1 and we will have 2 children, 3 children, 4 children, 5 children, 6 children, 7 children, and decrease them 1 by 1. You can see that it is working exactly as before, but this time we have made our composable stateless. This means that it doesn't have the state itself. It is only given the value of a state, and then it shows what we want it to show. And whenever it wants the state to change, it just requests the change via the lambda that we have given to it. Here, that lambda is onCount change. Box screen is using onCount change to ask us to change the value of count. So again, let me summarize. The technique that I just showed you is called state hoisting. It allows moving the state from inside a composable to outside the composable to its color. It makes your composable more flexible and more reusable, so that you can have different behavior for your composable based on the parameters that you are passing it. And this process is called turning a stateful composable. You can remember that the previous version of this composable was stateful, and we transformed it to a stateless composable. The current version is stateless. One more thing before I wrap up this video is that you can define the state and also its change handler in one line, thanks to Kotlin's destructuring assignment again. So instead of using this code and manually changing the value of count, in fact Kotlin has a way of doing it automatically. So we have the count here, and I can say, for example, var count and onCount change. Here the second value or variable that I am specifying is responsible for changing the value of the first variable. So this is a lambda, and Kotlin does that automatically behind the scenes, and it knows that this is responsible for changing the value of count. And we cannot use delegates this time. We use the equal sign, and uncount change, count uncount change. And in order to use it, we simply say uncount change, and we pass in the new count. There we go. So you can use this format of defining your state and its change handler as well. And because here we don't change the value of count explicitly, we can change the var keyword to val, like this. Again, I run the code to make sure and show that it is working as before. Increase. Great. It works without any change in the action and in the performance, just like before. So with these simple techniques, we were able to turn our composable that was stateful to stateless composable. And you can see that in the beginning it might seem a little bit complicated and a little bit like magic, but it's very beautiful, and I hope that you like this video.